Good morning. I just want to apologize in advance because I know this video is about to be quite long, or at least longer than my videos for the beginning of this week. So I just want to give you guys as much extra practice and review before you take your, I don't want to call it a test, but it's more of a bigger quiz than like an attendance quiz on Thursday. So tomorrow, Thursday, you're not going to have a video from me. You're just going to be taking this bigger quiz during your usual class period. So if you forget what class period you're in or you forget what class time starts, I'm going to post those in Remind and just kind of give you a heads up of when all you should take this quiz, okay? So before we get into the actual review, I wanted to remind you guys about this link, this Google Meet. So I'm going to post this in Canvas again, probably in announcements, but there's all the information that you need. So if you want to pause it, you can write it down. But basically, if you just click on this link, it should just go to this website and it'll actually ask you to like sign in. And once you sign in, I'm going to say don't allow me to use the microphone. You should say allow. But what happens is you'll hit join now, and I'm going to be on this all day, Thursday especially. Like I'll try to be on all day for Wednesday. So when you're watching this video, but this is a great way for you guys to just ask me questions live instead of like through texting, because I know a lot of miscommunication can happen through Canvas or through email. So if you would rather just talk to me face to face, like we can meet on here. If I'm not on here, it's been not telling me like when people join. So if you try to join and it says I'm not here, like I'm not responding, just send me a quick message in Canvas or email or Remind, and I'll be sure to get on, okay? But for sure on Thursday, like I'll be watching this like a hawk in case any of you like join. My advice would be to have in one tab like your quiz in Canvas, and then don't exit out of that Canvas tab, because then you're going to be locked out of your quiz. Instead, open up a brand new tab and then copy in this link, okay? So don't make it more work on yourself and get locked out of the quiz. But that's all I have to say about that. I just want to make sure you guys have all possible ways of getting a hold of me. And if you're in my 3rd or 5th period class, I know Mr. Delph is still having conferences every single day during the typical 3rd and 5th period. So if you would like to chat with him, he is also available. But let's get started with some problems. So I know this looks kind of funny because I have like, I obviously wrote in these numbers and then it's all typed. That's because I took this from a review that I had and I just chopped up some of the questions. So there's, I think, 14 questions. Yeah, 14 questions. So that's why I said this video can be pretty long. If you want to, just try them on your own. And then if you get stuck, come back to the video. Like, that's fine by me. One thing I will say that you guys have to have out is that reference sheet, the quadrilateral properties reference sheet. I do not expect you to memorize all of those properties. Like, I don't even have all of them memorized. I might at the end of this week because I've been using them so often. But I have it right out here on my desk as well. So I'm not expecting you all to remember them. So please use that to your advantage when you're taking notes and when you're taking this quiz on Thursday, okay? So with number 1 through 4, they're all based on parallelograms. So if you want to kind of hone in on just those parallelogram properties, those should be all you need for these types of problems. So if EBCD is a parallelogram, let's try a red thing. EB is 16, so EB is 16, and ED is 25, and BF is 11. Okay, and EC is 34. I'm going to try to make note of that here. And then the rest is angles. I'm not even going to do anything with the angles just yet because I don't want to mess up my picture too much. So we know that for parallelograms, the opposite sides are congruent. So EB is 16. That means DC is also 16. And the same is true when we talk about these two opposite sides, BC and ED. So let's see if those are any of the ones I find. So BC, 25. And then CD down here is 16. Now the other two I'm guessing are going to be with the diagonals. So the first one I'm trying to find is BD. BD is this entire diagonal. I only know half of this diagonal, and I'm referring to the property that the diagonals are bisecting each other. So it's creating two equal halves in this diagonal. I don't necessarily know that these diagonals are congruent. I just know that they're bisecting each other. So if BF is 11, that means FD is also 11. So then to find the entire length of that diagonal, I'm going to take 11 plus 11, or you could do 11 times 2, which gives me 22. Then for FC, FC would just be half of this diagonal. Again, they're bisecting each other, so FC would be an equal half to EF. So I'm going to think about what's half of 34. So 34 divided by 2, which gives me 17, which would be FC. Now I'm going to erase and come back. So I'm going to fill in my, what I know. BED is 55, BED, so right here, 55. CDB, CDB would be this angle right here. Make it red. And that is 67. And then BCE is 24. BCE. These are all angle measures, so I kind of forgot the degree signs. But, so the two properties that deal with angles in parallelograms are that opposite angles are congruent and the consecutive angles are supplementary. So remember, consecutive angles are the ones that are like right after one another. So this whole blue angle and this angle right here, those would be supplementary to each other. So when I find the measure of EDC, EDC would actually be this entire angle here. I'm not quite sure that this angle is being bisected at all. That's not one of the rules. So I'm going to take 180 and subtract 55 because I know that this blue angle and this entire angle, EDC, should be supplementary because they're those consecutive angles. So I'm going to take 180 minus 55 to get 125 degrees. Next, I am going to find EBD. So EBD would be, EBD, I'm going to actually mark that. It's that yellow angle. Now, this is when alternate interior angles come into play. So if I look at this yellow angle and this red angle, those would be alternate interior angles because this FD is acting as the transversal and then BC and ED are parallel to each other. So since those are alternate interior angles, they have to be congruent. So this is 67 and EBD is also 67. Next, I'm finding angle BEC. BEC would be, make it black. BEC is just that part of that angle. So I don't know if this is being bisected at all, if this angle is being bisected. So I couldn't take 55 and divide it by 2. But I do know that if I compare, and reminder, this entire blue angle is 55 degrees. But I know that this blue part that's not shaded black should be an alternate interior angle to this green angle here. So this little part of the blue angle should be 24 degrees. And then whatever this black angle is that I'm trying to find, they should add up to that 55 degrees. So I'm going to take 55 and subtract 24 to get that black angle BEC. So 55 minus 24 to get 31 degrees. And lastly, angle DBC. So DBC, this is again kind of like this angle down here that we just found. I know that this angle is 67 degrees, so I'm going to make note of that. And I actually know that this angle EDC, which I already found, is 120. So let's do this. It's 125. So I can take 125 and subtract 67 to find this remaining angle here, which would be congruent to this remaining here that's not the 67 degrees. So hopefully that makes sense. I know color coding is kind of hard when you have to deal with so many angles. I'm going to take 125 minus 67 to get 58. All right. Moving on to number 2. Number 2, you're just dealing with 2 angles, and you're finding the measure of angle N. Well, I don't know anything about angle N just yet, but I do know that K and M, angle K and M, are opposite angles. And so one of my properties are opposite angles in a parallelogram are congruent. So I'm just going to set those 2 angles equal to each other first, because once I find X, I can know a little bit more about those angles. So 8x plus 17 equals 12x minus 39. I'm going to add 39 to both sides. Sorry, my handwriting is awful today. Bring down my 8x, and I get 8x plus 56 equals 12x. Subtract 8x. And 56 equals 4x. When I divide by 4, I get x equals 14. Okay, so now that I know what x is, I can plug in x for either one of these angles and figure out what angle M and K actually are. So I'm going to plug it in for angle M. So the measure of angle M should be 12 times 14 minus 39. And I get 129. So angle M is 129. Now I have to think about what's the relationship between angle M and angle N. Well, they're not opposite angles. So the only other property that deals with angles has to be that the consecutive angles are supplementary. So that works. Angle N and M are consecutive. They're right next to each other. And so whatever angle N is, it has to add to 129 to get 180. So I'm going to take 180 and subtract 129 to figure out what N is. So 180 minus 129 equals 51. So the measure of angle N equals 51 degrees. And if you have no idea where that 180 came from, the word supplementary means that the two angles add up to 180 degrees, okay? For 3, we're using kind of a similar idea. We're finding angle R. I don't know anything about angle R just yet, but I do know something about U and T. U and T are another example of those consecutive angles, so I should add them up and set them equal to 180 degrees because that's what they should equal. And using that information, I can make an equation that I can solve for x then. So I'm going to take 5x minus 6 plus 14x minus 4 equals 180. Okay, if you just set them equal to each other, that doesn't make any sense because we don't know that they're actually equal to each other. So then I'm just going to combine my like terms. So 5x plus 14x, I get 19x. What's going on? And then negative 6 minus 4, I get negative 10 equals 180. Add 10 to both sides. 19x equals 190. Divide by 19. And x equals 10. All right, now knowing what x is, you got to be smart at where you plug it in, because if I look at angle R should be congruent to its opposite angle, which has to be angle T. So instead of plugging in x for both of these, I'm just only going to plug in x for angle T, because that's the only one that would be congruent to angle R, and I can immediately get my answer. So when I plug in x for angle T, I'm going to have 14 times 10 minus 4, and that leads me to measure of angle R is 136. Okay, so in number 4, ED is 7x minus 13. Okay, so that's just half of the diagonal. And then BD is 16x minus 38. So BD is actually the entire diagonal. So I can't just take these two equations and set them equal to each other, because that doesn't make sense. That you're saying like a half is equal to a whole. So instead, I'm going to take the half, this ED, and make it a whole by adding it twice. So another way of adding it twice is to multiply it by 2. So I'm going to take ED, the measure of ED, multiply it by 2, and then set it equal to BD. Okay? So 2, maybe. Oh, I think my hand was resting. So then 2 times ED would be 2 times 7x minus 13 equals, and then BD is 16x minus 38. And I'm finding BD, so whenever I figure out x, then I can just plug that in for this equation right here, which is BD. So I'm going to first distribute, and I get 14x minus 26 equals 16x minus 38. Okay, I'm going to, let's add 38. I get 14x plus 12 equals 16x, subtract 14x, and 12 equals 2x, divide by 2, x equals 6. Okay, so now, like I said before, we just have to plug in x for BD, since BD is what we're solving for. So I'm going to have 16 times 6 minus 38. And so then BD equals 58. problems 5 through 7 all deal with rectangles, so make sure you have all the parallelogram properties in your brain as well as the 2 other properties for rectangles. So rectangles have 4 right angles and the diagonals are now congruent. So looking at number 5, again, I'm only going to start with the sides. I'm not even going to think about the angles just yet. So if I have AD is 9, AD would be here, and AC is 22. Now I'm going to find BC. BC would be the opposite side to AD, so BC has to be 9 as well. And AB, so here's the thing about AB. I don't know what CD is. CD would be the opposite side to AB. But I do know that this right here is a right triangle. If I kind of highlight that. Okay, and it's a right triangle because a rectangle is made up of 4 right angles, so my right angle is right there. So I'm going to have to use Pythagorean theorem to figure out what CD is, and then I can use CD to find AB. So I'm going to have X is going to be one of my A or B sides. Doesn't matter which one. So I'm going to have 9 squared plus X squared equals 22 squared. Just like that, A squared plus B squared equals C squared. My 22 is my hypotenuse. So if I take 9 squared, I get 81 plus X squared. Can't do anything with that yet. And then 22 squared, I get, do some fast math. And so then I'm going to subtract 81. And I get X squared equals 403. And then to get X by itself, I'm going to take the square root to cancel out that X squared. And so I get X equals 20.1. Again, perfectly fine to get decimals when you're doing Pythagorean theorem. It's almost inevitable that you'll get a decimal, just because of these aren't going to always be pretty problems, like I like to say. The next one, BD. BD is this other diagonal. One of those properties are that the diagonals in a rectangle are congruent. So if AC is 22, that means BD is also 22. And then EC. EC is actually only half of these diagonals. So I'm going to take half of 22 because, again, those diagonals are bisecting each other. That's just one of those parallelogram properties. So half of 22 is 11. Starting off, I erased all my side links and side measures because they don't really help me when I'm using or finding angles. So the only angle I'm told in the directions are BCA. BCA would be this angle right here, and that is 66 degrees. Well, the other thing that I know about rectangles is that all their angles that make up a rectangle are 90 degrees. So next, if I'm looking at the measure of angle ADC, ADC is one of those right angles that I just talked about, so this would just be 90 degrees. The next angle, angle BAC. BAC is actually, we're going to have to do some work. So BAC would be just this part of that right angle. So if I look at this 66 degree angle, I'm going to just make the other alternate interior angle that would be congruent to that. So I'm going to make note that this is also 66 degrees. So if I know that these two angles are congruent because of alternate interior angles, and this is making up a right angle, I'm going to take 90 and subtract 66 to find that remaining blue angle that forms this 90 degrees. So 90 minus 66 would give me 24, and that would be angle BAC. Next, I'm finding angle CDB. CDB is this guy right here. The thing about CDB is it's the same as BAC, and what's happening is you kind of have to visualize that there's two pairs of congruent triangles in this rectangle. So one pair would be triangle ABE is congruent to triangle DEC, okay? And so whatever this blue angle is, it's going to be congruent to this angle here. Oh, I meant the highlighter. As well as these two green angles, which I might just make blue so it makes more sense. Okay. So angle BDC or CDV, however you want to say it, is also 24 degrees. Okay. And you really, like, I know I always say don't assume, but we can prove this, and I would have shown you how to prove it if we were in class. It just would take way too much time. So just you gotta kind of take my word for it that there's two sets of congruent triangles. Here's a set, and then here's a set. Okay. And then angle AEB. Angle AEB is one of these obtuse angles. I'm gonna make it. Let's make it red. We don't have a red angle. Keep doing that. So it's this obtuse angle right here. So it has to be more than 90 because it just looks larger than 90 degrees. So instead, we're going to use the fact that all angles in a triangle add up to 180 degrees. So I'm specifically looking at triangle ABE right now. So if I know that this blue angle is 24 degrees, and this angle is also 24 degrees, I'm going to see what adds to 24 and 24 to get me to 180, and that would be this red angle right here. So really, you're taking 180 and subtracting 24 twice to get 132. So if I took 24 plus 132, that should add up to 180 degrees, which makes sense with this being a triangle, and all of the angles inside a triangle add up to 180 degrees. So dealing with rectangles, PR is 9x plus 1, so PR is one of the diagonals, and QS is 13x minus 11. So QS is the other diagonal. So this turns out to be a pretty easy problem because those diagonals should be congruent to each other. So I'm going to take 9x plus 1 equals 13x minus 11. Add 11 to both sides. 9x plus 12 equals 13x. Subtract 9x. And 12 equals 4x. And then you would divide by 4. And x equals 3. So, using that, I'm going to just plug in x for one of these. It doesn't matter which one because they should be the exact same thing. So, I'm going to do 9 times 3 plus 1 to get 9 times 3 is 27 plus 1, 28. So I know that this entire diagonal is 28. Now what I have to do is I'm finding TR. So TR is only half of this diagonal because, again, they're bisecting each other. So I'm going to take half of 28 to get 14. So TR equals 14. For number 7, I'm dealing with angles. So angle DEG is 4x minus 5. DEG would be here. And angle FGE is 6x minus 21. So FGE So it turns out those two angles are, in fact, alternate interior angles, and so they should be congruent. So all I have to do is just set these two equations equal to each other. So 4x minus 5 equals 6x minus 21. Add 21. 4x plus 16 equals 6x. Oh, not divide. Subtract 4x. And 16 equals 2x. Divide by 2. X equals 8. Alright, so I know what x is. Now I'm going to use that to find DGE. So DGE would be this angle right here. So I have no idea what that is, but I do know that this red and yellow angle right here are forming one of those 90-degree angles in a rectangle. So if I figured out what angle FGE is, I could subtract that from 90 to find that remaining red angle. Okay, so I'm going to plug in X for one of these to figure out what these yellow angles are. So let's do 4 times 8 minus 5 to get 27 degrees. So this angle right here is 27 degrees. So if I take 90 minus 27, that would give me my remaining angle DGE, which would be 63. And that's it. Okay, we're more than halfway there, so hang in with me. The next topic for 8 through 11 are all rhombus questions. So with number 8, I'm going to zoom in. There we go. With 8, we're given this angle right here. In rhombi, they all have 4 congruent sides. The diagonals are perpendicular to each other, so let's make a note of that right there. Okay. And the diagonals are bisecting opposite angles. So what that means is this diagonal is bisecting this angle. So if this is 36 on this side, it's also 36 over here. So let's just make note of that as well. And whatever it is over here, it's the same thing over here. So we can make a lot of notes already just with that one angle. So we're going to find first angle JKL. So JKL, so that's just the sum of these two guys. So 36 plus 36, I get 72 degrees. Then the next angle is MLK. So MLK is actually this entire angle right here. I'm going to put it in green. Now I got to think about parallelogram properties, because what happens is if I combined this angle and this green angle, those would be those consecutive supplementary angles. So I'm going to think about, and again, this entire angle is 72. Let's make note of that somewhere. 72 degrees. So I know that something added to 72 has to be 180, and whatever that something is would be this green angle. So 180 minus 72 would give me 108. Next, I'm finding angle JMK. JMK is one of those 36-degree angles, so that's pretty easy. We already had that written down. Next, I'm finding MJL. MJL would be right here. Okay, so I'm going to specifically look at this entire green angle and compare it to just this gray angle. Again, this diagonal JL is bisecting both of these angles. So I'm going to take half of 180, and it should be the same thing for this angle, this angle, this angle, and this gray angle that we're trying to find. So half of 180 would give me 54. And that comes from the fact that the diagonals are bisecting the angles in a rhombus, and opposite angles are congruent in rhombi as well. Last angle, KNL. KNL, that is just one of those 90-degree angles where the diagonals are intersecting each other. So this is creating a 90-degree angle here as well. Okay, in number 9, it said we're using JKLM from the last question, so I just copied and pasted it again over here. And then we're going to use actually side links for this one. So if MN is 20, MN is here. And JL is 26. Just hitting all kinds of buttons today. Find JK. So JK would be here. I'm going to use the fact that JK, like all of the sides of a rhombus, are going to be congruent. So it doesn't really matter which one of these you find because they're all going to be the same thing. I think for me, the easiest way to look at it is just MN right here, just because it's the closest to me, quite honestly. So then if I know MN is 20, JL is 26, I'm going to think of what is half of JL, because that would tell me what NL is. So I'm going to take half of 26 to get 13. So I know that this part is 13 as well as this part is 13. And then again, we have to remember that these diagonals are perpendicular, so there's a right angle right there. Okay, so now you can hopefully see that we've created a right triangle that I'm outlining horribly right now. And what I want to find is this side right here, this X. Whatever X is, that's going to be the same for JM, JK, and JL. So this X, where it's located in this right triangle, would be my hypotenuse. So I'm going to take 20 squared plus 13 squared equals X squared. A plus B equals C, okay? So let's do it. 13 squared, actually. Plus 20 squared equals X squared. 13 squared plus 20 squared gives me 569. Okay. Then I'm going to take the square root. And so I get X equals 23.9. So ML is 23.9. JM is 23.9. JK is 23.9. And KL is 23.9. So there's my answer. All right, so in this one, I'm given two angles. Again, this is a rhombus, so I know just looking at these two angles that they should be congruent to each other because that diagonal is bisecting this entire angle. So I'm going to start with 9x minus 43 equals 5x plus 1. And I'm going to add 43 to both sides. Subtract 5x and get 4x equals 44. And so x equals, divide by 4, I'm getting ahead of myself. X equals 11, okay? So I'm using x to figure out what SVU is. SVU should be congruent to this entire angle here. So I can just plug in x for both of these angles. They should be the same thing, so I only have to plug it in once and multiply by 2. And that would tell me exactly what SVU is. So 9x, whoops, 9, I now know what x is, so 9 times 11 minus 43. And I want to multiply that by 2 because I want to add it twice. You could plug in x for 9x minus 43 as well as 5x plus 1, and you're going to get the same thing, which is, why can I not think? 26. So, not 26, 56, jeez. So 56 times 2 is where I get 112 degrees. So the measure of angle SVU is 112. All right, I don't know about you, but I'm getting tired. There's a lot of problems. Oh, okay. So, hopefully, take a break. If you've been watching this, like, straight through, take a break, because I need a break, so I'm going to take a break. Okay, so there's a lot of information in 11 that they give us. The first one I'm going to start out with is AD and DC, mainly because those are two of the outside sides in a rhombus, so they have to be congruent to each other. So I'm just going to take both of those equations and set them equal to each other and figure out what x is right off the bat. So 4x plus 2 equals 7x minus 13. Add 13. 4x plus 15 equals 7x. Subtract 4x. 15 equals 3x. Divide by 3. And x equals 5. All right, so x equals 5. So I'm going to actually plug in x for, let's do DC. So 7 times 5 minus 13. And I get 22. So this side right here, as well as all of these sides around the rhombus, are 22. So now I'm going to, let's see, it gives us BD. So BD is here. BD is 34. I already kind of see where it's going with this. So I'm going to cut BD in half to only find half of this diagonal. So half of 34 is 17. So I know this part is 17 as well as this part. Okay, and then again, let me just write 22 over here. And if I'm finding AE is this side, which I don't know anything about AC. If I knew what AC was, I could just cut AC in half, just like I did with BD. But I don't know what AC is, so I'm going to use the fact that this is a right triangle, and AC is going to be like my X, okay, another X. So I'm going to take and use Pythagorean theorem. So x can be my a squared. So I'm going to have x squared plus 17 squared equals 22 squared. Okay. I'm going to subtract 17 squared from 22 squared to get x squared equals 195. Take the square root of both sides, and x equals 14. This was one of the few times that doing Pythagorean theorem you actually get a whole number. So since x is 14, that means AE is 14, and we are done. 12 should be pretty easy because, again, your only two answers for 12 and 13, or 12, should be either 90 degrees or 45 degrees because we're just finding angle measures. So again, a square has all the properties of a rectangle and a rhombus and a parallelogram. So it's got everything. So one thing I'm going to point out are all of these angles outside are 90 degrees, as well as these diagonals are meeting to form perpendicular angles. And then where these right angles are down here, when they're being bisected, that means 90 degrees is getting cut in half. So just half of this angle would be 45 degrees. That's where the 45 degrees come from. So now we have everything. I think we need to solve these pretty fast. Angle WXY. WXY is just one of those 90 degree angles forming the square. So this would be 90 degrees. Angle XZY. XZY. So that is actually one of those angles that's being that's formed from the right angle being bisected. So that's one of the 45 degree angles. Angle XYZ, or not XYZ, oh my goodness, letters. YXZ is again just half of the right angle. So that's another 45 degree angle. WRZ. WRZ is one of those angles formed by the diagonals. So that has to be 90 degrees. Try to make that look more like a 9. And then angle XWY. XWY is again one of those halves of the 90 degree angles. So 45 degrees. In 13, we're using the square from the previous problem, so I just, again, cut and paste from the last problem. We're told that WY is 32. So WY is 32. Find XY. So XY would be here. I know that both of these diagonals are the same thing. So WY is the same as XZ because the diagonals are congruent. That comes from the rectangle properties. So if both of these are congruent, that means all of these halves should also be congruent. So I got to think of what is half of 32. Half of 32 has to be 16. So I'm actually going to erase this 32. And I'm instead going to put that this is 16 and this is 16. Because now, knowing this is a right angle here, we're again left with a Pythagorean theorem problem where this is my triangle. Okay, and that side XY turns into my unknown side, so I'm going to call it X, and it's actually the hypotenuse, so I'm going to have 16 squared plus 16 squared equals X squared. Okay, and solving for X, 16 squared plus 16 squared gives me 512. Then I'm going to take the square root to cancel out that X squared, and X is 22.6. So XY is 22.6. Okay, so for 14, we've done at least 8 examples on these now. So I think I'm just gonna skip through a lot of my math, like I have been doing. If you are still getting these wrong, I highly, highly suggest downloading one of those calculator programs I talked about, either Desmos or the Calculate, I think it's, let me see. Calculate 84, okay? So this is, I just always sign in with Apple. It doesn't really matter. My fingerprint. So this calculator, once it pops up, there it is. This looks exactly like the calculators we use in school. So you can even put in the square root button and put it in exactly as I would put it. So 2 minus 5. And then here's the caret button right below the clear button, squared. And then you can make it look exactly like how I put it on the screen. And then you're always bound to get it right. Like, the calculator's not going to mess it up as long as you put it in exactly as I have it on the paper, okay? Because I think that would be the biggest mistake you guys have made if you're getting these wrong still, is just putting in your calculator incorrectly. So I'm going to start with 14 by drawing a picture. Again, I didn't even explain the directions for this, but you're trying to classify whether or not this is a parallelogram, a rhombus, a rectangle, or a square. So step 1 is to check the sides. So I want to make sure I'm actually checking the correct sides. So I want to see if AB is congruent to CD, and then if AD is congruent to BC, or if all 4 of those sides are congruent. Of the distances that I need for step 1, instead of showing that opposite sides are congruent, I actually showed that all 4 sides are congruent, telling me that this is either a square or a rhombus. So now I'm going to move on to step 2. Okay, so for step 2, I checked the distance of the diagonals, so AC and DB, AC, DB, and checking their distances, I saw that they were not congruent, so this has to be a rhombus, because rhombus don't necessarily have congruent diagonals, only squares do, squares and rectangles, but we already narrowed it down to square rhombus. So ABC has to be a rhombus. All right, that's all I have. Your quiz today in Canvas it's not really going to be about these notes per se. It's more so just going to be me checking in, see how you're doing, and to make sure you know that there is a quiz on Thursday. Okay, so please reach out. Let me know if you guys need help. Yeah, good luck. Sorry this was such a long video. I promise this will be like the longest, and I will do my best to not make one this long ever again. Okay, bye guys.